Hi viewers, welcome to LMS Solution. Today we are going to see about Jellyfish Search Algorithm based optimization of PID controller. So this is the Simulink model we developed for optimizing of PID controller by using Jellyfish Search Algorithm. Here we are consider a second order plant and it going to be controlled by means of PID controller. Here you can see that the output of this plant is going to be taken as feedback and it going to be compared with the reference signal, and then in the error going to be processed via PID controller, and PID going to be provide control signal for this plant in order to track that reference command. Here we are going to optimize the parameter of the PID like KP and KI and KD by minimizing the error. Here we are going to minimizing and the mean absolute error. Mean absolute error going to be considered as the objective function. We have to find the optimal value for Kp, Ka, Kd by minimizing this mean absolute error. For minimizing the mean absolute error, we are going to use Jellyfish Search Algorithm. For Jellyfish Search Algorithm, you can refer this paper. This paper is published in the Applied Mathematics and Computation. The title of the paper is Novel Metaheuristic Optimizer Inspired by Behavior of Jellyfish in Ocean. So we can refer this paper for more detail about jellyfish optimization, because here the jellyfish algorithms developed based upon that behavior of jellyfish in the ocean. Here you can see that it is having 6 stage jellyfish in ocean, and then ocean current movement, and then jellyfish is moving toward to the swarm, and then here you can see that jellyfish passive motion, and then here you can see the jellyfish active motion, and then here you can see that jellyfish bloom. For different kind of action behavior of jellyfish, they created a equation for that jellyfish search optimization. Just you have to refer this paper for more information about that jellyfish information. We are going to use jellyfish search algorithm for tuning that PID parameter KP, K and KD. This is the code for that jellyfish search optimization. Here you can see that first you have to provide a number of population and then next number of iteration, and also you have to call this simulation for getting that error. That error will be stored in the workspace. After that you have to take a mean absolute error for that workspace data that going to be considered as a objective function or fitness function. Here you can see that the jellyfish search algorithm with a different stage. First you have to define the problem definition, and then you have to define the jellyfish search parameters, and then you have to calculate the cost function, that mean population, and then you have to calculate the cost function. This main iteration or main loop. Here first they are calculating the time controls C of t using equation 17, and then they are calculating the ocean current equation, and then they are going to for calculate the fitness value for that ocean current population, and then they are going to apply that inside movement of jellyfish in this form. They are applying that concept, and then they are calculating that solution for that, and then they are calculating the data. They are going to apply for active motion and passive motion, and then they are calculating the new cost function, and then you have to they going to replace the current best with the comparing with the current best with the previous best, and then they are suffering, that means swapping that data, and then finally you will get the optimal value for that KP and KS. The code is developed between the other, that means I told you that this other developed that code. We use that code in that optimization of PID controller. Already simulate the model. Here you can see that so already iteration is completed, 100 iterations completed. Final iteration, so after completion of 100 iteration, here you can see that this is a final KP and KA and KD value. This is the final KP, KA, KD value that going to be stored in the PID controller. Here this will be stored in the model workspace. We can see that data here. Explore and go to model workspace. Here you can see that the data will be stored here. So or you can again you have to simulate that model. That means here you can see that is a final value. Just you go to type KP equal to 44.9405 and K equal to 0.114216, and then KD equal to 0.4992. This data will be available here. We need to call that value into the model workspace. Go to that, and then here you can see that value. Just you go to copy this one, and then you can paste in the model workspace. Delete and paste. Now we have that optimized value from that Jellyfish algorithm. Now I'm going to simulate this model, and then we can see the final result. This is the final result response of the after optimization of that PID controller parameters. For getting the better result, we have to do a lot of trials. We must do nearly 100 trial in order to get the better result. So this is the working of Jellyfish search optimization algorithm for tuning of PID controller. Thanks for watching our videos. Kindly subscribe to the channel and also hit bell icon for notification about upcoming videos. Thank you. Thank you so much. Bye bye.